You can see.
Yeah, we should always have a laptop.
Yeah, this is so nice. Yeah, we can use food.
Then please not you.
Yeah, because he'll sleep. Good. He can really sleep. So fast.
Today's 14th, and I got some notes for you. We're gonna learn a couple new things. So the first thing is evaluating composed functions. And we do not go super deep, nasty, like difficult with this. Evaluating composed functions. Um, Yeah, so let's get right to it. By the way, when you compose two functions, and we will, if depending on how many math classes you go on to take, we'll do a whole bunch of this at very, very much more difficult levels. But when you compose two functions, basically you're kind of putting one function into another. So I have four examples, and then we'll draw the halfway point, and then I've got four examples of the second half of this as well. And these don't take long. The trouble is like they could be confusing. So hopefully they're not too bad. So we're going to have two functions up here. The first one, his name is f. He's a function of x, and he's a square and take away 10 guy. The second function, his name is g of x, and he's pretty boring. He's a doubler and then add 3 kind of guy. So these two functions are going to play together in the same problem. And what we're going to calculate is f. Well, here, let me write it, and then you can tell me if you want to try to pronounce what it says.
Function of the function negative.
Kind of. And you don't have to say the word function. So just try saying it using, bless you, just F and G.
Of G of -3.
I couldn't have said it better myself. That's how you speak these, is you say exactly what Pumpkin Spice said, and that is F of G of -3. The way you're going to do these is you're going to work them from the inside out. And it starts with just basically understanding that the output of one is going to become the input of the other. And that won't make any sense until we actually do one. So our first priority is to take out the innards. And so really what I want is I want what's in this red box to not be a math problem. Like I just want it to be a number like 2 or -5 or 10 or something so that I can find f of whatever it is. But the red box is not a number yet. It will be soon. So what we're going to need to do is two math problems here. We're going to start by calculating the red box. And the red box says we need to find g of -3. And having been hanging around and doing some work now, that should be absolutely simple for you guys. We're going to go to the function named g, that's the second function, and we're going to write it out as 2 times blank plus 3. And what are we going to put in the blank? -3. And if I put -3 in the blank, then I just have to do math. Very simple math. What's 2 times -3?
-6.
And what is -6 plus 3?
-3.
Good. So what we just did is we actually just took the red box and we can now replace it with just an actual number. So what I mean, what I said earlier is that the output of the g function is going to now feed in as the input of the f function. So what this problem up here in the yellow bubble actually says now is not f of g of -3, but rather f of the answer, -3. So we have to do one math problem to unlock the input of the second math problem. And what is f of -3? Well, that's just x squared minus 10. And what goes in the blank?
-3.
What is -3 squared? It is in +9. Remember that when you square something, it turns to positive because it multiplies by itself. And then 9 minus 10 is?
-1.
So the answer to the problem is that f of g of -3 equals -1. Again, the output of the inside one becomes the input of the outside one. Wow, that's a mouthful. If you're looking at that right now and thinking that's difficult, I totally understand, but also understand this, that it won't be here in a little bit. Once it clicks the process, Nothing to it. All right, so let's do another one. We're going to have a function this time named h of x. And what he does is takes our input and multiplies it by -6. And then he takes away 1. And then we also have a function named j of x. Hi. And what j does is he squares our input and then multiplies that answer by 2 and then adds 3 to that product. So we are going to find h of j of 0, like this. What math problem do we do first?
So,
Yeah, kind of the second one that you say is the first one that you do. That's how I always remembered composition functions when I was a kid. If I say it second, I do it first. So when I hear myself say h of j of 0, j of 0 is the one that goes first. I'll put a little yellow box around it for you. So when I want to calculate j of 0, that means I'm going to put 0 in place of x in the function named j. So to show a little bit less work here, check this out. I can use arrows. I can just say, I'm going to put 0 right there. And I know to go there because, again, I'm evaluating j of 0. This is one where I don't feel like I need to show much work. What is 0 squared?
0.
And what is 2 times 0?
0.
And what is 0 plus 3?
3.
3. So really, this math problem right here is actually asking us to find h of 3. We just had to calculate the one inside the big parentheses before we could finish it off. And now we're back to the beginning of the process, kind of. We're back to evaluating a function. So I'm going to do h of x. So I'm going to do h of 3, which is -6 times blank minus 1. Output of one becomes the input of the other. That should kind of be feeling like it's making sense now. And what do we put in those parentheses?
3.
3, because that was the output of the first part of the problem. What's -6 times 3?
-18.
What's -18 minus 1?
-19.
Good. So we say that h of j of 0 equals -19. Still good? Okay. Ready for round 3? You good, bud? Jackson, you good? Okay. Our first function is going to be named g of m. And what he does is this. He cubes, and then he triples the square, and then he takes away twice the input. And then we have a function named h of m. These are both functions that, they eat m's, if you will. They process m's. And this guy is -3 times m plus 15. And we are going to calculate h of g of -2. I try to do my parentheses staggered. The computer may not always do a good job of that. So I try to make my inside function be a little bit kind of more compressed, just so the parentheses line up a little bit better. They don't feel as awkward. But if a computer doesn't just understand, the language is still the same.
that's -2 in the front.
It is, yes. It's h of g of -2. Correct. So what math problem are we doing first?
H of m. No, wait. No, G of m.
Correct. And I'm going to keep doing this, and I'm going to keep doing it until I make sure that every one of you is okay. Giving you lots of opportunities to ask if you're not okay. Inside is the one we do first. So we need to just go off to the side and do something that by now, it's something we've probably done 30 or 40 times. That's just a simple evaluation. So I'm going to go find the function named g. That's up here where the star is at. I know to use that one because I'm doing g. And I'm going to copy the function down, but every time I get to the input m, I'm going to leave a space, parentheses. So this function g would say this. Blank cubed plus 3 blank squared minus 2 blank. I don't think we've ever seen a function that had 3 feeding slots, but it doesn't matter, right? An input's an input. And so all of those parentheses are just openings waiting to be fed an input. And our input is what?
-2.
Right. We're told so in the red box. And so we're going to feed -2s into these. So there's one there, there's one there, and there's one there. And now the order of operations, Mr. Bosley Bridges steps in. There are 2 math problems up here that we can do before all the others. What are they?
Exponents.
Exponents have got to go first, right? We got to give that full respect. When people say do the parentheses, I'm always really concerned. And that's why I don't teach PEMDAS, is because there are no parentheses in this problem that require being quote unquote done, right? These are just hold in place parentheses. They're not like that. So exponents say, knock us out first. And so I'm going to say, okay, you and you. Just the 2 math problems that I've circled need to go first. What is the answer to this first one? -2 to the third.
-6.
It is neither of those. Don't forget what it means. If we could combine your 2 answers into one, oddly enough, you guys would have had it.
-8.
It is negative, first of all, and it is 8. So it is -8. What it looks like, what -2 to the third looks like, I'm going to write it over here in yellow, is this. -2 times another -2 times another -2. That's what -2 to the third quite literally means. And so, yes, if you pair them off, these first -2's make a +4. And then this 4 times the leftover -2 gives us -8. Okay. Now, the second yellow circled thing is -2 squared. What does that equal?
+4.
It does equal +4. So I'm going to copy down the +3 times +4. And then I'll just copy down the -2 times -2. Now that the parentheses, the exponents are out of the way, it's on to multiply and divide. And I do see 2 multiplication problems that have to go first. So one of them is in this red, and then one of them is in this green, right? So the -8 in front just is like, I guess I'll just hang out and wait while you guys do whatever. What is 3 times 4?
12.
So we're going to put a +12. And then what is the answer to the green egg? +4, because it's like a -2 kind of times the -2, which is +4. There's a lot more meat on the bone with some problems than others. So a couple that we've done, or at least one of them, was pretty straightforward at. But sometimes it's a lot of work. And we're still in the first part. So, but we can finish now. What's -8 plus 12? And what's 4 plus 4?
8.
Great. So we could now say that the answer, going all the way back to the very beginning, this took a while, was that the answer to this red box right here, I'll put an arrow pointing to it. The answer to that box right there is 8. So what the problem from the very beginning now actually says, this math problem actually says what it meant to say in the beginning, and that is go find h of 8. Because remember, we now know that g of -2 has a value. We figured out the value. We figured out it's 8. So the problem now says to go find h of that answer, h of 8. And this will be a lot easier now because the h function is a lot simpler. It's this one. I'll circle it in purple, put a box around it for you. And that's one that I think we can all just do in our heads. That's one of the simple pimple guys. So if you take 8, follow my long purple arrow, here it comes, and you put it right there in that math problem. What's -3 times 8? -24. And -24 plus 15 is -9. Done. That was a pretty, say again? -9. Yep. Got it. That one was a little rougher. Let's do one more real quick. Okay. You guys feeling it? Easy? Okay, good. Let's go round 4. We'll take a tiny little short break, like a minute. We're going to have two functions. One of them is named f of a. And what he does is takes the opposite of the input squared and then adds 11. And then the other one, his name is j of a. And what the j function does is he takes 50 times the input and then subtracts 104. And what we're going to calculate is j of f of -3. I don't think you could have sat through this and not know the answer to this question, but I have to ask it for a fourth time while I pour some coffee. What is the first math problem that we have to do? Thank you. Good. F of -3 is our priority. I need to take that j of blah, blah, blah and make it into j of something, like j of a number, right? So the idea is I need to take what's in this red box and do this math problem first. Try to be very deliberate with my notes with you guys. It's a process that you can repeat again and again and again. So we have to do the math problem that is the red box. And to do the red box is to use the f function that's up here with the star. And I'm going to draw a little arrow down to here, and it's going to look like this: negative blank squared plus 11. What's going into the blank?
-3.
Yeah. There are math problems written in red and white at the lowest point of writing on the TV. What has to go first?
Exponent.
The exponent goes first, right? And please understand, as we've discussed before, that this negative right here that I'm pointing at is not part of this. He has to wait, right? So don't try to put those negatives together. That would just make the math gods angry. What you have to do is just that yellow oval, only that. And what is -3 squared? It is +9. And so when I bring down the answer to that yellow egg, which is +9, I have to remember then to transfer, follow the purple here, that negative has to transfer down and become a label for the 9. So we have -9 plus 11, which is definitely +2. So the red box equals 2. Neat. So what in reality does the green math problem really say? What does it say? What can I now write it as? I couldn't hear that. Thank you. Good. There it is. We figured out the answer to the red box. We put it back in, and now we can evaluate the j function. J was not evaluatable until we gave it a meaningful input, but now it has a meaningful input. J of 2. I can handle this. So the j function is in this green box. So I'm going to copy that function down over here, and I'm going to write 50 blank minus 104. And what goes in the blank?
2.
2. And this is another one where I don't think you probably need to show much work. What's 50 times 2?
100.
And what's 100 minus 104?
-4.
Therefore, we can say the final answer to the problem is -4. You guys got it? Okay. Would you like just a short little break, or you want me just to finish this off? The second part won't take as long. It's a lot. Should knock on wood. I think it's a lot easier. That can be very confusing at first. I hope right now you're sitting here, all of you, thinking, the first one I was lost, but I'm good now. I can do this. And if you're not, I hope that you'll ask. But again, I think this last part is easier. So what we're going to be doing on the second half of this is evaluating functions, but we're not going to be given numbers as inputs. So for example, these are not compositions, by the way. You could make a case on some level that they could be, but they are not. So what they are is, here's a function, f of x equals 3x minus 8. Is a very simple function, but what I want you to find is f of x plus 4. And again, if I've done a good job and if you've done a good job, if we worked well as a team and getting you to understand the how does this work, like the moving parts, then you're not going to feel any stress about this. You're going to understand that this is going to go right in place of this. Like that, I hope I've done a decent job in the last couple attempts at this to show you that that's just all we're doing, right? You're plugging something in into the feeding slot. So what the function f of x is now going to say is going to be 3 times blank minus 8. What's going to go in that blank? It is not 4.
It's X.
It is not x.
Thanks, Bill.
Now, there it is.
Yeah.
So that's difficult, and I tried to be very visual about it. But again, I need you to understand that the red box from the right transfers over and gives all of himself as the input into the function f. He says, wherever you used to see an input slot, change it to say x plus 4. Okay? And now we have a very simple math problem to do, some very low-level distribution. We have 3 times x and 3 times 4. What's that going to equal? So 3x plus 12 minus 8, which finally equals what?
3x plus 4.
Nope. That's the final answer to the problem. Will actually have variables in it. When you substitute or input a variable value into a function, it's going to logically give you a variable value back. Let's try that again. This function is going to have a different name. His name is h, and he is a function of n. He says, feed me n's. And he's like, this is what I do. This is how I behave. Whatever you give me, I'll multiply it by -4. And what I want us, mostly you, but us to find is h of -3n. And I'm going to do this again. I'm going to continue to try to be as visual as I can because this can be a little bit confusing. Not for everybody. Some people, it just varies from one person to the next. You see the red box I just drew? It is going to go, all of the stuff in the red box is going to fly over where this arrow's pointing and replace this red box over here. That's it. One in for the other. That's all functions do. So the function up here, h of n, is now going to say -4 times blank. And what's going to go in the blank?
-3n.
Oh, you answered that much more authoritatively that time. Great job, guys and gals. And now we simplify. And what is -4 times -3n?
No, yeah.
Just positive 12n. Done. Put a box around it, full send, on to the next one.
That's it.
Yep. These can be a lot more difficult, and they will be in April and May after I've taught you some polynomial operations like squaring binomials and things like that. But for today, I have to keep them at a pretty simple level like this because we haven't done polynomial operations yet. Let's try again. This function, does anyone want to guess the function's name? Nope, it's p. Does anyone want to guess what the input variable is? T. 12's not a variable, homie. So we have a function named p. He's a function of t. And he says, this is what I do. I'm a function that just adds 5. Feed me something and I'll add 5 to it. I'm a pretty boring guy. So we come back at it and say, okay, well then let's do p of -6t. Again, visual. I was a visual learner, and I selfishly assumed then that others are as well. So you see the red box? The contents of that red box are going to transfer themselves right into where that other red box is. Done. What is the answer?
-16 plus 5.
Done. Put a box around it. It's over. Why are we done? Well,
Because you can't simplify.
because you can't simplify it any further. Those are not like terms. Last one. Feeling okay?
Yeah.
Are you feeling kind of like what Cal said? That's it, like pretty easy? Okay. Last one, and then it's work time after this. So our last function, anyone want to guess his name? No, get good, noobs. G. What's the variable? What's the input?
F.
Nope. G of x. This function says, here's what I do. I'm going to take whatever input you give me and multiply it by -4. And then when I'm done messing around, I'm going to add 12. And that's the answer that I'll give you back out. So we turn around and say, okay, tough guy, I'm going to feed you x minus 3. So for the fourth straight time, I will show you that the input is x minus 3. In other words, the contents of that box will fly over here and replace this box. The people that will struggle with this, this is not across the board, but if you do find yourself struggling, it's probably because you're not showing enough work. So some people will show less work and still be fine, but others, I'm telling you, if you hit a wall, it's probably just not showing enough. So I'm going to show the function again. I'm going to put -4, and where it used to say x, I'm just going to put an awkward void kind of thing there, and then plus 12. And what's going in that awkward void?
X minus 3.
Correct. And then we'd like to think that September and half of October have been well spent in the sense that no one is going to mess up this distribution. What is that going to equal?
-4x plus 12.
Perfection. Good job, everybody. Catching your negative, distributing to a negative, turning it into a positive.
Like terms.
And these are the like terms right here. What do they make?
24.
So our final answer is -4x plus 24. Jackpot. Box it up. Full send. How do you feel? Good? Your assignment is not on Delta Math. It is on Canvas, which I think I published it, but I should probably go check real quick. Publish. Boom. So there'll be a little thing at the bottom that says, here's today's video. Obviously, it doesn't exist because I'm recording it right now. That's weird. But eventually it'll pop up there on Canvas for you. In the meantime, just click on assignment 9. It'll pop up and you just do the problems on your own paper. Okay. Let me know if I can be of assistance. I'm going to pause the recording, but keep it alive. So if anyone says, hey, can we go over this or whatever, then I'll throw it in the recording for you. So problem 1 on your homework looks like this. By the way, if you totally understood the lesson, oh, by the way, I misspelled evaluate. That is not me not knowing how to spell. That's just a fat finger. I know how to spell evaluate. I'll fix that. If you're in the group of people that would have just answered that question as a 1 and would have said, I don't know what's going on, then this time is obviously for you. So let's get to it. So in problem number 1, we're being asked to find g of h of -1. What is the first math problem that we have to do? Good. So this red box goes first. And so that means that I have to take -1 and put it right up where this little arrow is pointing right here. And I know to put it there because it's h. So I use the correct function, h of -1. And I feel like we can do this probably in our heads. What is 3 times -1? I can't have you doing that.
Oh, wait, no, negative.
Yeah, I just can't do it. -3 plus 4. Say again?
1.
+1. Yeah. So the answer to the red box is, what is that? 3, 1, right? So in reality, the overall problem, which originally said g of h of -1, it now actually says just g of 1. Which means that now we're going to take our output, like our answer, which is 1, and we're going to put it where the purple arrow is pointing up here. And yes, I am about to ask this question out loud. If I put 1 in place of x in the g function, what is 1 plus 1?
2.
So the answer to this problem is 2. Done. Box it, send it. So in this batch of problems, we're doing kind of what we did in the first part of the notes. We're evaluating one function, getting an answer, and then putting that answer in place of the input in the other function. I mean, I don't know how else to explain that. So if anyone else is still having a hard time, I really need you to advocate for yourself and speak up, because I don't want to just sit here and go through all your homework with you. So let me know what I can do to assist you. And if you get it, good job. Just keep rocking. Okay.